Class 10 Acids and Bases, lecture number 4. How strong are acid or base solutions? Very simple. It depends on H plus and OH minus ion concentration. If H plus ions are more, strong acid. If H plus ions are less, weak acid. Similarly, OH minus, H plus for acids, OH minus for bases. Let's see what is mentioned here. We know how acid-base indicators can be used to distinguish between an acid and a base. Just to distinguish purpose, we can use indicators. We have also learned in the previous section about dilution and decrease in concentration of H plus and OH minus ions, right? So by adding water, the concentration of H plus and OH minus will be definitely decreasing. Can we quantitatively find the amount of these ions present in a solution? Can we judge how strong a given acid or base is? Yes, we can. We can do this by making a use of a universal indicator, which is a mixture of several indicators. The universal indicator shows different colors at different concentration of hydrogen ions in a solution. So just based on the color, you can decide what is the concentration of H plus ions. Quite interesting. A scale for measuring hydrogen ion concentration in a solution called pH scale has been developed, where P indicates potence. The P in pH stands for potence. So a scale for measuring hydrogen ion concentration in a solution called pH scale has been developed. And here pH in P is potence, which means power. On the pH scale, we can measure the pH generally from 0 to 14 under normal conditions, but under 25 degrees Celsius temperature conditions and all, 0 to 14, pH should be thought of simply as a number of which indicates the acidic or basic nature of solution. Okay, so pH means you are just saying about the H plus concentration. If H plus concentration is more, that is acidic, less, that is basic, and the values and all we are going to see now. Higher the hydronium ion concentration, lower is the pH value. Higher is the hydronium concentration, lower is the pH value. Simple word. The pH of a neutral solution is 7. Values less than 7 on the pH scale represent an acid solution. As the pH value increases from 7 to 14, it represents an increase in OH minus ion concentration in the solution, that is increase in the strength of the alkali. So 0 to 7 acidic, 7 is neutral, 7 to 14 is basic. Simple one word. Generally, paper impregnated with the universal indicator is used for measuring of the pH. See here, H plus ion is given blue color. That means here H plus ion concentration is more. When we reach near 7 neutral, both are same. And here OH minus ion concentration is more after 7. So when you are reaching 14, that is maximum with OH minus concentration. When you are at 0, that is almost with H plus ion concentration. But remember, bases also contain H plus, acids also contain OH minus. But in case of bases, OH minus concentration is more than H plus. In case of acids, H plus concentration is more than OH minus. Both will be there. H plus will be there, OH minus will be there. But H plus concentration is more than OH minus in acids. OH minus is more than H plus in bases. So coming to these values, I have checked remaining books and I found these values. Okay, I didn't do any experiments. Saliva before meal light yellow, pH 6.5 slightly acidic. Saliva after meal light yellow, 7 neutral. Lemon juice yellow, 2 pH acidic. Colorless aerated drink like Sprite and all, light yellow, 3. Carrot juice, 6. Coffee, 5. Tomato juice, 4. Tap water, 7. Sodium hydroxide, 14. 1 molar. HCl is 1. Okay, colors you can check. Colors little interesting. Here the colors are mentioned. Gastric juice about 1.2, lemon juice about 2.2, pure water 7, and sodium hydroxide 14. The color you see, this is blue in color, this is red in color. That is what we are writing here. HCl red in color, NaOH blue in color, water green in color, 7 is green in color. So based on these pH values, we mentioned their colors. The strength of acids and bases depends on the number of H plus ions and OH minus ions produced. Perfect, na? Respectively, means for acids H plus, for bases OH minus. If we take hydrochloric acid and acetic acid of the same concentration, yes, hydrochloric acid is strong, acetic acid is weak, because hydrochloric acid gives more number of H plus ions, as hydrochloric acid dissociates completely. Say 1 molar, both are of 1 molar concentration, then these produce different amounts of hydrogen ions. Acids that give rise to more H plus ions are said to be strong acids, and acids that give H plus ions less said to be weak acids. In the given, the HCl is strong, and this is strong acid, and the acetic acid is weak acid. All organic acids are weak acids. Can you say now what weak and strong bases are? Weak means less concentration of OH minus. Strong means OH minus concentration will be more. Simple. Importance of pH in everyday life. Are plants and animals pH sensitive? Definitely. Every living thing is pH sensitive. Our body works within the pH range of 7 to 7.8. Living organisms can survive only in a narrow range of pH change. When pH of rainwater is less than 5.6, it's called acid rain. When acid rain flows into the rivers, it lowers the pH of the river water, and survival of aquatic life will become difficult. Very, very important. Acids in other planets, the atmosphere of Venus is made up of thick white and yellowish clouds of sulfuric acid. Do you think life can exist there? No, absolutely no. Normal rainwater only, little bit acid rainwater only, we are not able to digest. There is sulfuric acid water. Dhamal. What is the pH of the soil in your backyard? Plants require a specific pH range for their healthy growth. To find out the pH required for the healthy growth of a plant, you can collect the soil from various places and check the pH in the manner described below. In activity 2.12, also you can note down which plants are growing in the region from which you have collected the soil. Put about 2 grams of soil in the test tube and add 5 ml water to it. Shake the contents of the test tube, filter the contents and collect the nitrate in a test tube. Check the pH of this filtrate with the help of universal indicator paper. What can all blah 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 blah. Practical thing is, we generally don't do all activities. We just write what actually happens. And in your backyard, the pH range will be generally 5.5 to 8, and this is good, ideal for plants. If it is more acidic, add some bases. If it is more basic, add some acids. pH in our digestive system. It is very interesting to note that our stomach produces hydrochloric acid. It helps in digestion of the food without harming the stomach. During indigestion, the stomach produces too much acid, and this causes pain and irritation. To get rid of this pain, people use bases called antacids. One such remedy must have been suggested by you at the beginning of this chapter. These antacids neutralize the excess of acid. The best examples are given here. Magnesium hydroxide, milk of magnesia. A mild base is often used for this purpose. I told you strong should not be used. If you are using strong, there will be acid and base reaction, a lot of heat will be released. So mild we need to use. And one of the best mild is milk of magnesia. pH change as the cause of tooth decay. Tooth decay starts when the pH of the mouth is lower than 5.5. Tooth enamel made up of calcium hydroxyapatite, a crystalline form of calcium phosphate, is the hardest substance in the body. Tooth enamel is the hardest substance in the body. It does not dissolve in water but is corroded with the pH in the mouth if it is below 5.5. Bacteria present in the mouth produce acids by degradation of sugar and food particles remaining in the mouth after eating. So when you are eating more sugar, okay, now that sugar will be converted to acids. When the acid quantity is increasing, the pH will come down below 5.5 and tooth decay will take place. The best way to prevent this is to clean the mouth after eating foods using toothpastes, which are generally basic for cleaning of the teeth, can neutralize the excess acid and prevent tooth decay. Common sense. Self defense of animals and plants through chemical warfare. Okay, Have you ever been stung by a honeybee? It's paining. Na? Yes, bee sting leaves an acid which causes the pain and irritation. Use of a mild base like baking soda on the stung area gives relief. Stinging hair of nettle leaves inject methanoic acid causing burning pain. This is that plant. Nettle is a herbaceous plant which grows in the wild. Its leaves have stinging hair, which causes painful stings when touched accidentally. This is due to the methanoic acid secreted by them. A traditional remedy is rubbing the area with the leaf of the dock plant, which often grows beside the nettle in the wild. Very interesting. No? And both the plants are together, and one gives pain, second one gives relief. Can you guess the nature of the dock plant? So next time you know what to look out for if you accidentally touch the nettle plant while trekking. Are you aware of any other effective traditional remedies for such things? Ask mama, she will tell you. Otherwise, ask your grandfather, he may knows. Some naturally occurring acids: vinegar is acetic acid, orange is citric acid, tamarind is tartaric acid, tomato is oxalic acid. Vinegar, acetic acid; orange, citric acid; tamarind, tartaric acid; tomato, oxalic acid; sour milk curd is lactic acid; lemon is citric acid; and sting is methanoic acid. Nettle sting is also methanoic acid. So these are some commonly occurring, naturally occurring acids. So 2.4 we'll discuss later. These questions we'll see. You have two solutions A and B. The pH of solution A is 6 and pH of solution B is 8. So this is acidic, this is basic. Which solution has more hydrogen ion concentration? Definitely 6 wala, because that is acidic. Which of this is acidic? 6 wala acidic. And which one is basic? 8 wala basic. What effect does the concentration of H plus ions have on the nature of the solution? It makes it acid. If H plus ion concentration is more, too much of H plus ion concentration, then it will become acid. If H plus ion concentration is less, then it will become base. More H plus ion concentration acid, less H plus ion concentration is base. So it definitely depends. Do basic solutions also have H plus ions in ions? Yes, definitely. Just now we were discussing. Definitely all bases will have small amount of H plus, all acids will have small amount of OH minus. If yes, then why are these basic? Because the concentration of H plus ions in bases is very less. Under what soil condition do you think a farmer would treat the soil of his fields with quicklime, slaked lime, or calcium carbonate? You can see calcium carbonate or calcium oxide or calcium hydroxide, all are bases. When he's adding bases means its field is already with acidic nature. So if he is having acidic soil, then that can be converted neutral by adding bases. So that's acidic. This will go in next class. Thank you.